So my voice isn't quite back to normal yet, but we'll go ahead and muddle through the next section, which is section 2.2 and 2.3, linear equations. So we did talk about linear equations already for a little bit in an earlier video. Remember, linear equations have a highest degree of 1. You've probably seen them most often in this form, which is the slope-intercept form. And just realize that both y and x are raised to the first power. So there's an implied power of 1 on those. That's what makes a linear equation linear. They do appear as a straight line, so we can have a linear equation that looks like this, or it can look like this, or it could even look like that, or that. And we'll talk about the different appearances and the different ways to look at linear equations a little bit later. Lastly, remember, linear equations are representative of repeated addition. And this is what our slope represents. Because it's a straight line, it has a constant slope, which means for every set increase in our input, we see the same increase or decrease in our output. For example, if this is 5, 10, 15, 20, this could be 6, 8, 10, 12. We see for every 5 unit increase in input, we repeatedly add 2 to our output. This brings us to the forms of linear equations. There are 3 forms we'll focus on. There's standard form, which is the form ax plus by equals c, where a, b, and c are real numbers. There's slope-intercept form, y equals mx plus b, where m and b are also real numbers, but m is the slope of the line, and b is the vertical or y-intercept. And lastly, there's point slope form, y minus y1 equals m times x minus x1. And again, m is a real number, and m is the slope of our line. We use the different forms depending on different situations. For standard form, the reason we have a standard form is because every linear equation can be written in standard form. Not every linear equation can be written in slope-intercept or point-slope form. For example, x equals 5 is a linear equation. If we were to graph that, we would get a vertical line at x equals 5. This form right here, x equals 5, is in standard form. But because there's no y in the equation, it is impossible to write it in slope-intercept or point-slope form. This is why we have a standard form, so that we have a form that every possible linear equation can be written in. Slope-intercept form is also a very valuable form, and one that you're probably most familiar with. Slope-intercept form, which is our y equals mx plus b, is particularly useful because of m and b. These values give us information about our graph. M tells us the slope. So if m was 5, we would know that our graph is increasing by 5 for every 1 increase in our input. And b is our vertical intercept. It tells us where that graph crosses the vertical axis. Linear functions, so this is a little bit different than a linear equation, are always written in slope-intercept form. Because in a linear function, we have x as our input and y as our output. So we always get f of x, which equals y, equals mx plus b. Next one is point-slope form. And point-slope form is particularly useful if you know the slope and the point of an equation already. You can just plug them into that form. To see an example, continue on to the next video.